is that it breaks down a problem into multiple different pieces. And within each piece, you will come up with the best solution within each piece. And you'll make the best solution in each piece without thinking about the other pieces. So each piece is independent of one another. And that can raise a few issues, which I will talk about later on. So I think the best way to explain what the greedy algorithm, or as I like to call it, the greedy concept is just through an example. So we're just going to go over an example where we need to print the least amount of bills that are needed for like a certain amount of dollars. So like, let's say we need to give someone $36 and they want it in the least amount of bills. We could use like the greedy concept to come up with the least amount of bills that we need. And it's not going to be, we're not going to implement this concept the same way for every problem. It'll be a bit different, like each problem will be a bit different, but the general concept is still the same at the end. So when we want to print out the least amount of bills, we can just start at the highest number. So in this case, you can start at 20s, and then we can go to 10s, 5s, and 1s. And what we can do here is like, I'll just show the steps here. Yeah, so you want to put in as many 20s as possible in the beginning. So we can only put in 120 in the beginning. So we would have 36 minus 20, and then that'll give us 16 left over. And then now that we've done the first step, now let's go on to the second step. And these are the pieces of the problem. So like here I have 4 steps, which are kind of the 4 pieces. And these steps are independent of one another. So for the 10s, wait, excuse me 1 second. Yeah, so the next step that we would want to do is we want to put in as many 10s as possible into our number 16. And then that would, if we do 16 minus 10, which is 1 bill, we would have 6 leftover dollars. And we would put in as many 5s as possible and then as many 1s. So there's nothing too special about it. It's a pretty simple concept, just breaks down the problem into different pieces. Another example that I have is, let's say you have like a few activities that you do, and there's like a start and finish time for it. And the goal here is to figure out how many activities can we do, like the maximum amount of activities we can do. So if we look at this example, activity 1 starts at 12, ends at 25, and you can read the rest of it, I'm sure. So if we just look at the problem here, I'm sure it's kind of obvious that we would do activity 2 and then activity 3, and that would give us 2 total activities. Because if you were to do activity 1, that time is overlapping into 2 and 3. So you won't be able to do activity 3 after you finish activity 1, because activity 1 ends at 25, which goes into activity 3's starting time. And here we can also use a greedy algorithm to do this problem. So here you would, I'm not going to go over the exact solution, or I'm going to go over the solution, but what I'm trying to explain here is like how we're using the greedy algorithm. I'm not going to go into the solution of the actual problem itself. So what we can do is we can sort the times by the finish time. And what that would look like is on this next slide here, I sorted it by the finish time. Activity 2 would be first, then 1, then 3, because the finish times are increasing. And for each activity after the first one, you just want to check for if the start time is after the finish time of the previous activity. And and that might seem a bit confusing. I'll just explain it on the next slide. So here for activity 2, it finishes at 20, but the next activity, it starts at 12. So we can't do activity 1 afterwards. So we would have to go on to activity 3. And this is like one of the pieces of the problem, and we're just coming up with the solution for it. We're not exactly looking at all the numbers at once. We're just looking at it piece by piece. And that's where the name greedy algorithm kind of comes from. Or not the name, that's kind of what the concept of the greedy algorithm is. So a limitation of the greedy algorithm is it kind of thinks like a 5-year-old. That's how I like to think about it, is that it will look ahead of itself and see what the best solution is for the short term, but it won't look at the long term. So let's say you start at this at 0, and you want to come up with the least expensive way to get to the end. The greedy algorithm will choose the path that starts with 1, but then it won't understand that there's a 1 million up ahead. Whereas the correct solution should be you go to node 3, then node 2, because it's only a value of 3. Whereas if we go up, it's going to be a value of 1,000,001. So that's kind of what makes the greedy algorithm a bit not the best choice in some types of problems, because you might run into this kind of situation where it only makes the best solutions in the short term, but doesn't think about the entire solution itself. Another example I have is trying to come up with, I kind of found this online, and it's trying to find the most, I think it was expensive way, or the most costly, like, I don't know what you could say about this, but you would just come up with the most expensive way, most expensive path, I mean. And here, if we do the greedy path, it's going to choose the highest number out of the 2 choices it has without thinking about the entire solution. So here it's going to choose the 10, and then it's going to choose the next biggest number, which is the 8. But in reality, the best solution was to actually take the 3 because there was a 100 afterwards. So those are the limitations of the greedy algorithm. And Kanishka and Ishan will go over a few problems and code some examples with you.
Should I do mine first?
Yeah.
Okay. So the 2 problems I'm going to be sharing are going to be on code forces. So you don't need to make an account to view them, and I'm going to paste the link in the chat. You don't need an account to view them, but if you want to like submit your code, you will want to make an account. So this first problem is called taxi. I pasted a link in the chat, and I'll give you guys like 2 minutes to read it and think of how you would solve it. Yes, that's correct. It looks only at the current step. Okay, so I'll explain the problem now. So, okay. Okay, so there are n groups of school children, and went outside and decided to visit Polycarpus to celebrate his birthday. We know that the ith group consists of s friends. So basically, each group of school children out of the n groups of school children has between 1 and 4 school children in it. And each group wants to go to Polycarpus together, and they decide to get there by taxi. And each car can carry at most 4 passengers. So what we want to know is what is the minimum number of cars that the children will need if all groups need to like stay together when they're transported. So the input for this is just the number of groups and how many people are in each group. So the solution for this was I first considered what is the easiest like group out of groups of either size 1, 2, 3, or 4 to like knock out first. And I decided that I would first knock out like all the groups that had 4 children in them, because a taxi can only carry 4. So if we want to get the total number of taxis, we can just add however many groups of 4 there are to the total. So before we do that, we first need to read in the input. So input, we have one number, which is the number of groups, and the next line has how many people are in each group. So all we need to know is how many of each group size there are. So we need to know how many ones there are, how many twos there are, how many threes there are, and how many fours there are. So to do this, I'll first make a scanner. And then I'll read in how many groups there are. So that's n, the number of groups. That's the next int. And then I will make an array for the 4 different numbers of school children. So this array will be 4 long. And this array will represent 1, 2, 3, 4. So like index 0 will be 1 and so on. And now we finally need to we need to count up how many of each size of group there are. So we can do a for loop and iterate through n, because there are n groups. So all we need to do is r at the next int minus plus plus. So we need to do -1 because these group numbers are from 1 to 4, while the indexes of our r are from 0 to 3. That's why we do -1. And we just do plus plus to count it. And an int array starts at a 0. So this works well. Now we need a variable to keep track of the total number of cars we need. So I'll call it total. And we decided that the first thing we'll do is take care of the 4s. So to do that, that's pretty simple. All we need to do is add how many groups of 4 there are to total. So it'd be total plus equals r at 3. Because the index 3 is how many 4s there are. So you can write this as 4 minus 1 if you want. Yeah. So after we take care of the 4s, the next thing we can take care of is the 2s. Because in each car of 4, 2 2s can fit. So next we can take care of the 2s. Like after this step, there are no more 4s. We only have groups of 1s, 2s, and 3s. So to take care of the 2s, we can just add however many 2s there are, which is at index 1, and divide it by 2. But if we do that, there might be an odd number of 2s. So to take care of that scenario, we can set the number of 2s equal to the mod 2 of it. So basically, if there's an odd number of 2s, there will be 1 left over. So that 1 would go into the 2 spot in the array. And if there's an even number of 2s, then this would be 0, and we've used up all of the 2s. So after this step, we've either used up all the 2s or have 1 group of 2 left. Next, let's take care of the 1s and 3s. Because if you put a 1 and a 3 together, they can form like a 1 full taxi. So like each of these form full taxis. And that's like the best choice at that point. So that's why it's like a greedy problem. So to take care of the 1 3s, we first need to figure out what is like which of like do we have less groups of 1 or less groups of 3? Because 1 car is a pair of 1s and 3s, so when you take the lower number of the 2, as how many pairs of ones and threes we're gonna have. So we can call that int min1 3, and that is just the math.min of the number of ones, which is r at 0, and the number of threes, which is r at 2. And then next, we can just add that to the total, because this is how many groups we can form with ones and threes. And then, okay, after this point, we've taken care of all the fours. We've taken care of all the twos, except maybe we might have one left. So we might have 1, 2 left. And, oh, I forgot, I missed a step. So after we make these pairs, we also need to subtract from like the original number of groups of ones and groups of threes. So the number of ones, we made min1 3 pairs. So we need to subtract min1 3 from how many ones there are. And we also need to do the same for the number of threes. So after we do this, whichever one of these two was the minimum is going to be 0 now, and the other one is might have some value. So you might have 1, 2 left, and either the threes or the ones are left. So to do this, we'll just first check if there's any threes left. So r at 2 is the number of threes. So if r at 2 does not equal to 0, we can just do total plus equals r at 2 plus r at 1. Because it's groups of threes, they have to go in their own taxi. That's why we can just add it normally. And we're adding r at 1 just in case we might have 1, 2 left. So if we have a 2 left, this is going to be 1 because of this mod. And if we don't, it's going to be 0. So this takes care of the case if there are threes left. This else means that there are ones left. So if there are ones left, what we need to do is just count up the total number of passengers and divide it by 4. So to do that, we would do the number of passengers, or the number of passengers is how many groups of 1 there are, and maybe that group of 2, if there is one group of 2 left. So we would do r at 0 plus r at 1, which is how many groups of 2s there are. And because groups of 2s have 2 people in them, we're going to multiply by 2. And what we need to do with this number is we need to divide it by 4, because we need to find out how many taxis it's going to fit into. And if we just do this will be doing int division, so it won't work, because you can't, int division just truncates the ending of the answer, while we want to round up, because you can't take like 5 people in one car. That's what this expression would give us. So to do double division, we can just divide it by 4.0. And we need to round up. So to round up, we can do math.ceil. So now we have the number of cars we need. So now we just need to add it to total, and that is our answer. And we can just print it and close the scanner. And this is the answer. So if we copy the input, we can run this, paste it in, and it gives us 5, which is what the output wants. So Should I do the second one as well, or do you want to do the Sherlock one, Ishan?
Yeah, you can do the second one.
Okay. So the
But
second
maybe we can
problem.
focus more a little less on coding it. We'll go through that part a
Okay.
little faster.
Okay, sure. So the second problem is remove smallest. And I posted a link to that in chat. And again, you can view it if you don't have an account. And otherwise, you can just, yeah. And I'll give you guys like 2 minutes to read it. So if there are no more questions, I think Ishan's going to do the next problem, which is based on Sherlock.
Yeah, so the link is in the chat. Just go ahead and it's actually a lengthy problem statement, so I'll explain the problem myself. So you don't have to read the whole thing. Pretty much, you have Sherlock and Moriarty playing this game, and they each have digits. So this line over here is the digits that Sherlock has. You can see he has a 1, he has a 2, he has a 3. The next line is what Moriarty has. He also has the same digits as Sherlock, a 1, 2, and a 3. And they're playing a game where they have their digits. They're going to line them up in some way. And whoever's digit, each time somebody has a smaller digit than the other person, that person with the smaller digit will get flicked. So in this example over here, Sherlock has a 1 in that place, Moriarty has a 3. So Sherlock's going to get flicked because his number is smaller. The 2's a tie, nobody gets flicked. And then over here, Sherlock has a bigger number than Moriarty, so Moriarty is going to get flicked. And in this problem, you've got to find the minimum possible number of flicks Moriarty can get, and also the maximum number of flicks that Sherlock can get. And you can arrange these digits in any way that you want, and you have to find the minimum number of flicks Moriarty can get, and the maximum Sherlock can get. So let's try to understand this problem better. This is Sherlock's numbers over here. This is what he has, and this is what Moriarty has. So in this example right now, Moriarty is going to get flicked once because 1 is smaller. This is a tie, and he's going to get flicked twice. But it turns out that this is not the lowest number of flicks he can get. The smallest number of flicks he can get is actually 1 if we line up these numbers in a different way. And so in the chat, I want you to take a guess at how we can line up these digits so that we can Moriarty only gets flicked once. You can take a guess at that. Yeah, so Madhu said 3, 4, 1, and that's correct. Because if we do 3, 4, and 1, let's just ignore this for now. If we do 3, 4, and 1, then Sherlock is going to get flicked once. He's going to get flicked twice, and Moriarty only gets flicked once because 1 is smaller than 6. So we see that the solution to this problem is to sort the numbers in order, because obviously we're dealing with stuff where how large the number matters. And to find the minimum number of flicks that Moriarty is going to get, we're going to sort the numbers, and then we're going to compare the we're the smallest numbers. So who of the two over here has the smallest number, Sherlock or Moriarty?
Moriarty.
Yeah, he has a 1. So what we know from this is that no matter what we pair up with this one will always be the smallest number. This 1 over here is always going to be smaller than all the other numbers because we sorted the numbers and it's at the front of the list. It's smaller than all of these numbers. So instead of wasting this 2 over here, which is the next smallest number, instead of wasting the 2 on the 1, instead we're going to give this 2 to the 3 because the 3 is bigger than the 2. And likewise, we're going to take this 3 and give it to the 4. So instead of lining the 2 up with the 1, because we know the 1 is going to lose no matter what. 1 is smaller than 2, 1 is smaller than 3, 1 is smaller than 6. Instead of wasting the small 2 on the 1, where the 1 is going to lose, where Moriarty is going to lose, We give the 2 to the 3 and Moriarty wins, the 3 to the 4 Moriarty wins, and we give the 6 to the 1. So that's the optimal lineup for Moriarty getting the fewest number of flicks. And the second thing that we needed to find was the most number of flicks that Sherlock can get. And this follows a similar principle. So does anybody want to take a guess at the optimal lineup for Sherlock to get the most number of flicks? Right now, he's not going to get flicked at all. Because 2 is bigger than 1, 3 is greater than or equal to 3, and 6 is greater than or equal to 4. So just like before, the optimal lineup will be to take the 2 and give it to the 3 and give it to the 4, and then the 1 and give it to the 6. To find the most number of flicks that Sherlock will get, we'll go through Moriarty's list over here, this 1, 3, and 4. And every time that Moriarty's number is bigger than Sherlock's number, we're going to increase the counter variable by 1 and go to the next number in Sherlock's list. So we start off with 2 and 1. 1 is not bigger than 2, so we just skip this. Then we go to the 3. 3 is bigger than 2, which means that if we line up a 2 and a 3, Sherlock is going to get flicked because 2 is smaller than 3. So we increase our count by 1, and then we go from 2 to 3. And we come over here and compare the 4 and the 3. 4 is bigger than 3. Sherlock's going to get flicked. We increase our count by 1. And then we go to the next position in Sherlock's array. So this is a really common technique that is important. It's called 2 pointers. It comes up in a lot of problems, not just greedy problems. And it comes up in a lot of contests like Code Forces. That's where the problem is from, USACO, a lot of places. So we're going to go ahead and code this, but I'm going to make it quick. This is handling the input over here, so don't worry about that. It's pretty long. And we have these 2 arrays, Sherlock and Moriarty. And like I said, to calculate the minimum number of flicks Moriarty can get, we'll have this variable m. And to start off, we're going to just set it to n. N is the number of digits that's in the game. So we start off the number of flicks that Moriarty has with n. And what we're going to do is we're going to go through each of the numbers that Moriarty has. And actually first we have to sort those lists. So arrays.sort, I'm going to sort Sherlock's numbers, and then I'm going to sort Moriarty's numbers. So now I have these 2 sorted arrays. And what I'm going to do is to calculate the minimum number of flicks Moriarty can get. I'm going to go through each of his numbers. And I'm also going to have a second variable to keep track of the position for Sherlock's numbers. Every time that Moriarty's number is greater than or equal to Sherlock's number, every time Moriarty's number, so more of I is greater than or equal to Sher of pause, that means Moriarty is not going to be flipped because his number is greater than or equal to. So we'll decrease m by 1, and we'll increase position, which is Sherlock's position in the array, by 1. And so that's how we calculate the minimum number of flicks that Moriarty is going to get. And then to calculate the maximum number of flicks that Sherlock can get, I'll say int s equals 0. We'll start that off as 1. And I'll also reset position. Once again, we're going to go through Moriarty's array. So I'll just copy this over here. We're going to go through his array again. And we want to count the number of flicks that Sherlock gets. So every time that Sher of pause is less than Moriarty of I, Sherlock's number is less than Moriarty's number. So what we're going to do is increase s by 1. This is just keeping track of how many times Sherlock gets flicked. So we increase it by 1 because his number is smaller. And we're going to go on to the next number in his list. And now we can go ahead and print out Moriarty's number space Sherlock's number. So if we copy this example here and run this. Oh, I printed out the arrays. That should be M, that should be S. Yeah, we get 0 and 2, which is correct. Then we run it with the second example. We get 2 and 0, which is correct as well. So that's how you do this problem. And this is a really good problem to practice once again on your own, because as I said, it's a concept that comes up a lot. It comes up very frequently when you're dealing with greedy problems and 2-pointers. You want to sort them, and then you want to find an optimal way to line them up. Yeah. Are there any questions about that or any of the other previous problems? Yeah, I could actually do this in one for loop. I could put this here, and then yeah, I can take that, put that there. I would need a second position variable, so I could have like int pos2 equals 0, and then there I have one for loop for it. So yeah, this will also work. So as homework, or if you have any free time, there's this problem on CodeChef called the Crofts game. You can take a look at it. This is another really good greedy problem that has to do with lining stuff up. And I encourage you to think about it for a while because it has a really nice solution. And then for the solution part of it, you guys can just like check it out later, at some point later. That's the solution. So yeah, that's the end of this week's meeting. Next week, we'll be doing some more with greedy problems. Just to give you a preview of the types of things you'll be doing where greedy can be used. So let's say you own a venue and you rent out rooms to people to host events. And I give you a bunch of times that people are coming, maybe from like 10 to 3, 10 to 5, 2 to 5. You have a bunch of events planned. You want to find the minimum number of rooms needed to host all of these events. And you don't want to have 2 events in the same room at the same time. Each event has to have its own room. And once the event is over, some other event can come in. So the solution to this problem actually to find the minimum number of rooms that's a greedy problem. We can solve it using a greedy algorithm. Another example, let's say you have a bunch of assignments due, you have how long it takes you to do them, and you have when they are due by, and you need to find the optimal order of the assignments to do them in to minimize how late they are. So that's another area where greedy solution can be used. So greedy problems are really applicable, especially for scheduling problems. You can take a look at that if you're curious and